Hello. Today we talk about events over SQL, thousands and millions of them, in fact. So let's start. What the idea is about? The concept is that we can use an SQL database as a backend for our events to store and publish them there. In a similar way as we use any message broker or event store like Kafka or RabbitMQ, but we can take advantage of the fact that we have an SQL database anyways and simplify our infrastructure. So here I have written a library that does exactly that. It's a Java library, so it's available on the JVM, but it can be ported to any programming language. So for the plan for the video, we go to the concepts of how it works more or less, and then we go to the benchmarks. We run them and see how well it performs. So let's start with the concept. What we need to have? We need to have a few tables. And tables, they represent concepts as well. So we have topics, consumers, and events. Topic is just a definition of an aggregate for events. In fact, it has a name. It can be partitioned. We go there in a while, and created that it's just an internal date. Consumer is per topic. It also has its name because we can have multiple consumers per topic, obviously, and it can be partitioned as topic is. And we have table per event. This means that table will be created, separate table will be created per topic with this name, so prefixed with topic. Event, similar as topic, it can belong to a partition, or if topic is not partitioned, it will belong to just topic, not topic and partition. And the tables are managed by library, as it is stated there. You don't need to think about it. All you need to do is to give library a database connection. We also have event buffer and event buffer log, but that's just it's needed because we need to have sequential ID in the event table with order guarantees. If you're curious how exactly it works and why we need that, I have also written a blog post about it. I will link it down below. But for now, let's go further. So then we have a concept of an explanation of how we can consume from these topics, how we can build consumers. Basically, we open transaction, we consume from the consumer table, from the topic and particular consumer that we are interested in. We use this useful for update skip locked clause. What it does is it will return rows, only the rows that are not currently locked. In this particular case, we can just have 1 or 0 rows. So if on another thread different process is trying to use this consumer, we will not get records here, which necessitates that one consumer can have only one processing process at the time. Because also, as you can see, we get events from the table of certain topics, and in the where clause we use the last event ID because that's the state of our consumer we don't store state by event, we just store the offset of last event ID. So we process events in order as they arrive, but the drawback is that each consumer can process events only on one thread, unless it is partitioned. We go there in a while, but just to finish this up, we begin transaction, we log consumer, then we get a batch of events from certain topic, we do something with them, and then we update our consumer once we are done with processing. And then we are committing transaction, obviously. And if something fails there, it will be aborted and retried in the next run. And as I said, we can have partitioned topics and consumers. So let's say we have a topic with 10 partitions. We then add this end clause to where selecting consumer. Same with selecting events from the event table. And then we also update only consumer that we have logged, obviously. And what it allows is to have as many parallel processing units per consumer as we have partitions. So if this consumer would have 10 partitions, we can process 10 partitions at once. And then also the order guarantees are changed, so events are then ordered only within partition, not globally in a topic. And that's mostly it. These are just examples of how we use tables that we already have, but the library is, as I said, written in Java. So we have an API here ready to be used. So as you can see, we can register topics, consumers, we can publish events to topics. Here it's an instruction of how we can customize partitioner. We know better this in the video, and then how you can consume from topics. And also we run benchmarks on with one Postgres instance, serving us as a backend for our events, but also then we use sharding. So 3 of the databases will be used as our backend, because we can shard EventSQL. And what it basically means is that we have instead of one database serving as a backend for our events, we have multiple ones. So we have just multiple data sources. We have 3 in an example, and we publish to each of them, and we consume also from each of them. And as we will see, we can linearly increase our throughput. Alright, so to run benchmarks, we will have Postgres in 3 instances on 3 machines. We have consumer app and the runner. And the runner is basically a publisher with some logic around how many events to publish, with what rate, and as to end with some logic of how to print the results in a useful for us way. For more important things, we'll publish JSON events like that, so it's some kind of account created event. And we can go to the consumer as well. So it's just a Spring Boot app create EventSQL instance. We have connections to databases, I believe, yeah, as many as we have in the properties, and we'll have 3 of them. They will be all enabled once we build those on this app. And yeah, they are all Dockerized. We deploy them to DigitalOcean infrastructure. So we have things here as I described. This basically is a readme of how to repeat the steps that we are about to do in the video. If you want to follow me, to have a DigitalOcean account as well. So we can basically start preparing to run those benchmarks, guys. To make it faster, I have run a few steps already. So I have run the prepare infra scripts. So as I will show you, and there is a screenshot of what you should have in your DigitalOcean console. So I already have those machines. So with that being said, let's actually build our apps. So first we need to build EventSDB. So let's package it. It can take longer for you because we use Docker. So if you don't have this exact image of Postgres 16, it needs to be downloaded. Alright, we have it. Then we need to build an app, consumer app. Here we need to have a few environment variables. So first db0 host. We need to have a private IP for that, and we need to have 3 hosts because I said first we run benchmarks on 1 DB, but then on multiple ones. And to get private IP, we need to go to this screen. So first host 0, then we have 1 and 2, and I believe that it will be just 3 ending as I did here, and for 2 it should be 2 as well, and let's also build and package it. Alright, we have it. If you are curious, it is here in the dist library directory, I mean, and you can see, as you can see, it uses the end variables that I have configured. So the last thing is runner, that we run our tests. This one. So let's also build it and package it. And once it is done, we will basically deploy our apps. First 3 DBs, then the app, consumer app, and 3 runners. So let's start with the event DBs, and right now we need to have the public IP addresses. So let's copy that guy. Oh, that's unfortunate. Also this one. Let's type it. So events db0 host and the IP address Then we have 1 and 2 as previously, but the IP addresses are public. And DB2, that's right. Yeah, having that, let's deploy them. That can take a while, because as we did in many previous videos, we have zipped Docker image and we are transferring it over to our droplets. And 3 of them. Alright guys, we have deployed EventSDBs. Right now let's deploy the consumer app. It's deployed to a different machine, dedicated specifically for it. So we need to give app host and let's deploy it in the same way as we did previously. Alright, we have deployed our consumer app. The last thing are 3 runners, each runs alongside the DB. These guys we have already exported, so we just need to run deploy runners, and this will be the last one before running our benchmarks. So let's wait one last time. Alright guys, runners are deployed, so we basically have almost all we need to run benchmarks. Before running them, let's monitor resources of one of the DB machines on which we will start benchmarks. So let's SSH there. We can choose any of them. It can be this one, and let's just SSH. We have a user like this, and let's give it an IP address. And let's see what we have here. EventSDB, and we will see them there, our running runner in a while. So let's export runner host, the same IP as we have SSH'd into. And right now we need to decide on events rate and events to publish. We can start with 1000 events per second, but that's pretty low. As you can see, it will not be changed at all. So I would say that for events to publish, don't need to wait like a full minute. Let's go with 20,000 events, which means that it should run for about 20 seconds with 1000 events per second, right? So let's run our benchmark. Yes, so we have started the benchmark runner on this machine, as you can see. It can use a lot of resources, but I mean the runner, but it runs tests, so we don't bother with that. EventSDB, as you can see, quite low. Remember that you have 8 CPUs, so 800% is our maximum. And we also have here a command to check the results of the benchmark. Alright, so as you can see, rate similar to as we wanted. Consumption is a little slower because it has certain delay because of events buffer, and also because we read events 1 per second in the loop, and we have slight delay to mimic processing. If you go to events consumer, here it is, as you can see. So it will always be a bit slower, the consumption, than publication in our benchmarks. But as you can see, the 1000 events per second is nothing. Let's go to the 5000 and let's increase the 100 events to publish to 100,000 as well, so it runs for more or less 20 seconds as well. And yeah, let's see. EventsDB, as you can see, so it's higher, but still less than 100%, and we have 800% at our disposal. You can see the logs publishing, and as you can see, we have the rate we wanted, slightly slower for consumption as well. So with that being said, let's go to so we can handle 5000 without any problems. Let's go with 10,000 and see what will happen. So let's bump the events to publish to 200,000 and let's run it again. Yeah, so we are running it. As you can see, EventSDB is over 100% right now. Let's see logs. Yeah, we are publishing. Okay, event. Yeah, as you can see, also very good results. 9,000 over 9,000. Let's go so close to 10,000. Let's go with 15 actually, and maybe for events to publish, let's bump it as well, and let's see what will happen. Can we handle more than 10,000 on a single Postgres instance? Yeah, so we are running it. As you can see, CPU is higher, over 200%, but we do have 800 as we remember. Let's check out the logs. Yeah, it has finished, and as you can see, we have handled over 10,000. Right? Yeah, so no problems with more than 10,000. Let's try it, guys, with 20,000. We had it slightly less than we wanted, but as we know from these benchmarks, they do have certain lags. So let's see what will happen with 20,000 and more events to publish. Let's run it. Right, more CPU is getting used, but we still have some room, space to use. Let's see the logs. Yeah, so as you can see, it's even better right now. 70,000 per second publishing and 13,000 consumption. That's really nice, guys. Remember that it is on one machine. So what I would do is to bump it even further to 25,000, right? Here. We will publish 500,000 events. It's getting to be a significant number. Let's run it. All right. CPU similar, around 300%. Let's see what we have in logs. Publishing. That would probably be our cap. Yeah, so waiting for consumption. Yeah, consumption so consumption is lagging, but as you can see, we have published 20,000 events per second and consumed almost 15,000 per second, which is a lot. So given that, as we can say that we can publish and consume 15,000 events per second, we can publish and consume. Let's see how it scales to multiple databases. So in theory, it should be linear, but let's see. So for the next thing, we will run it the same benchmarks, but on 3 databases. We have them prepared already, so we just need to export the different environment variables. So for runner 0 host, runner 1 host, which is this guy, and runner 2, which is this guy. Alright, and let's start with something less than we had lately there, but also not like with 1,000. I don't know, let's start maybe with with 10,000. We have here in the example times 3, of course, because it will all be published to 3 DBs and consumed from 3 DBs. Remember that. So with 10,000, let's go back to 200,000 events to publish, and let's run multiple DBs benchmark. Yeah, and what basically it does, it runs the same script as we have here, but on 3 machines in parallel, and our consumer app is consuming from all of those 3 DBs. Yeah, so for logs we can use the same thing. And as you can see here, we have 3 runner instances are running in parallel. Message in the logs. So yes, exactly, we'll have 13,000 events per second as a real rate. Alright, so we have finished, and as you can see, it was more or less linear, so 28,000 requests per second were published, and we have consumed 26,000. So we know that it's a lot, so I would go straightly to from 10,000 to 20, and let's bump our events to publish 2 times as well, and let's see what will happen, whether we can handle 20,000, publishing of 20,000 times 3, so 60,000 in total. Yeah, so resources are similar to our previous one single DB benchmark cap, because it's the same from the perspective of this machine. It just runs on 3 of them in parallel. Alright, so we are publishing. I mean, we finished publishing. Still consuming. Okay, it has finished. So as you can see, it was close to 20,000 per one machine, but multiplying in times 3, we had over 51,000 events per second published, and we have consumed almost 40,000 events per second, which is massive, which is a lot. And obviously we have 3 DBs. We can scale it to 5, 10, and so on to get to probably to hundreds, maybe even millions events per second. So for the last one, let's bump it to 25 and see whether we'll have slightly better results or not. And that will be all, I guess. Alright, so running it again. Yeah, lots of resources are being used as expected. And let's see what we will get. Yeah, so publishing is done. Let's wait for the consumption. Alright, so it's done as well, and as you can see, the results are slightly better. So we wanted to have 25,000, we got 19. Multiplying it is almost 60,000 events per second published, and over 40,000 events consumed. Which is a lot. Who needs that? Who needs that kind of throughput and performance? And as said, we could have 5 dBs, 10 dBs, and it would be not 3 times better, but 5 times better, 10 times better. Probably there is a cap on around, I don't know, 100 dBs or something, but the space for optimization is huge. Alright guys, so I think that's it. If you want to play with the library, just check out the Git repo. There are more details on how to use it and how to get it using Maven and Gradle. And also I will link more detailed blog post in the somewhere below. So If you like the video, subscribe to the channel, and I see you in the next one. Cheers!